I'm Andrew Ward, and this is my MAE535 project for design of electromechanical systems. For my project, I created a simple magnetorheological or MR fluid. So I took a bunch of iron filings, mixed it with some oil to provide a medium, and then I ended up adding some cornstarch because the first attempt, the iron particles were able to float around much more freely in the medium instead of actually moving the medium like I wanted. So here we have the fluid. So as you can see, when we take some neodymium magnets like this and put it near the fluid is attracted to it, and we can draw that around. And this of course happens because the iron filings themselves are attracted to the magnet. If you look really closely, you can see some little spikes of the iron filings as they group together along the lines of magnetic force. And so again, we have that moving this around. So there's some really cool things that can be done with that fluid. Essentially what we're doing when this magnet comes close to the fluid and the iron particles are drawn closer is we're changing the local viscosity of the fluid. So as you can see out here in the unaffected section of the fluid, I can stir it fairly readily. But as soon as I try to stir next to the magnet, it becomes much harder. So, some cool things that can be done with this. It is often used in some fairly advanced shock absorbers. When you get right down to it, a shock absorber is essentially fluid moving through some small holes to create resistance. So here we have the MR fluid going through the hole, and you saw the resistance there. When we add one magnet, the resistance to movement goes way up as the filings are drawn towards that magnet. And if we add two, the magnets actually overcome the force I was able to measure with my little Holmes scale. Another thing you'll notice in the last one is that after the fluid got moving, the resistance to movement decreased quite a bit. So that is another factor that we need to take into account. Another good idea that's been brought up for MR fluids is to be used as the fluid in between a hydraulic bearing. So a hydraulic bearing usually has a fluid in between two metal plates, which could be concentric cylinders or two flat plates sliding across one another. I have a simple demonstrator element made by some pans with some MR fluid between them. And so we have one pan sliding across the other. So we'll see what happens when we put some of these neodymium magnets on the bottom. And what we find is that with just two, it is now a little bit harder. I know you can't really see much, but it is actually a little harder to move that back and forth. If we add a third one, we're starting to get even more resistance to moving this back and forth. We can add even more braking power if we add one other magnet to the other side. So now we have magnets on both sides of the pan, and now we have some real resistance built up, and it is much harder to slide this across. You can see the magnet actually staying in the same place as it is being held there by the one on the other side. So now we have drastically increased that viscosity and that resistance to movement. That would be a very easy braking force to add. So something like that can very easily be used in any sort of motor where you have a hydraulic bearing. We replace the hydraulic fluid with MR fluid, and now we have a very quick way to change how much resistance we have, a very finite, measurable, and quick way to add or take out any of that braking power. And there you have it. So I made some very simple MR fluid, found some really cool things to do with it. I wish I could take some more specific measurements than I did. However, I did not have the capability to do that. But we have a very simple MR fluid, and we have some good things that we can do with it.